And if that is all kind of old news for you and you've been doing computer science for a while, think about it as an opportunity to see how you could run a professional development workshop virtually for the staff or volunteers that you work with. So I think if everybody has their supplies and we're ready to go, let's go ahead and start recording this session because we have some people who weren't able to join us in person. And we'll start with our first activity. Do we have the recording started, Anne?
Yes, it is.
Okay. I did not get the little beep that tells me that it is recording. Thank you.
Mm-hmm.
We're starting out today with an activity with palindromes, and hopefully that you have that handout and you can share that. Let me show you what the handout looks like. Anybody having trouble getting those supplies together? You know, you are all welcome to turn your camera on if you want to. It's always a little weird to not be able to tell who you're training with, but I see, thank you, Rebecca. I can tell that you're here because you are active in the chat. Oh, that makes it much easier. Okay. Palindrome, does this make sense? Do you have the handout? Thank you. All right. Palindrome is a number. It can be a word or a phrase too that is reversible. You read it both ways and it reads the same. Level, L-E-V-E-L, is an example of that. We're going to be looking at the handout that I shared. And I want you to pick out your favorite color out of those colors that you have available and color all the palindromes that are on your sheet. And I will give you a hint that single digit numbers are palindromes. So you can start with all of the single digit numbers and then look for others like 11 that would be a palindrome. So just take a minute to do that. And Rebecca and Jane, if you can hold up your handout when you're done, that'll let me know it's time to move on. Fast. Okay, so those are our simple palindromes. The next type of palindrome is called a one-step palindrome. And this is a bit of a formula. You take a number and you add the reverse of that number. So 45 plus 54, and that makes a palindrome. So take a different color and color in those one-step palindromes. Thank you. Ooh, that's kind of a cool pattern. Great. Okay, I'm gonna share my chart. I love playing around with this. So as you probably guessed, there are 2-step palindromes and 3-step, and it keeps going. So on my chart, the first palindromes are purple and my 1-step palindromes are pink. And my 2-step palindromes are blue. So as you're looking at your patterns, what do you notice? I just kind of like looking at patterns and structures this way. Anybody have any notices? Anything you can share in the chat, or you can unmute yourself and share what you notice? I had to do a little bit of calculating on my paper. You know, some of the numbers I was okay with adding. And others, it was a little harder. So you can see my calculations along the side there. Somebody's going to need to share an observation in the chat or by unmuting yourself, or else I'm not going to keep going. What do you notice?
Hello, this is Darren Snyder from up in Juneau, Alaska. I apologize for arriving late. I'm noticing that the lower, it looks like the upper left-hand corner is purple and pink, and the lower right are the more steps required. So I'm seeing that pattern just in the grid there.
I was really intrigued by that too. I have no idea why. I love playing around with numbers, but I'm not a mathematician. But I think that's really interesting too. The palindrome activity was an example of experiential learning. And I know many of the people that are in the workshop today are 4-H professionals, so you're probably familiar with the experiential learning model, but we're going to pretend that not everyone is. So experiential learning is one of the strategies we'll be talking about today. And the whole point of experiential learning is to engage learners in hands-on experiences and reflecting on those experiences. And that's because when you use experiential learning, your learners are going to be more prepared to apply what they're learning, their skills or the concepts in real-world situations. It makes it easier for them to transfer that learning. And it is one of the strategies we'll talk about for teaching computer science. So if you are taking notes today, we'll be brainstorming a list of strategies. So you could put down experiential learning as one of those strategies for teaching computer science. And we'll talk more about this later in the do, reflect, and apply process. But the point really is you start out by doing something. The experience comes first, as much as you can make that the case, and then sharing and reflecting on that experience is a crucial part of that process. So that's our first strategy for today. And I'm going to turn it, I was supposed to introduce myself. And I realized I introduced myself in the chat, but not in person. My name is Sandra Frericks, and I work with Nebraska 4-H, and I'm part of the Click to Computer Science team here in Nebraska. And I'm going to turn it over to my colleague, Anne, so she can introduce herself and take us into the next part of the activity.
Hello, my name is Ann O'Connor, and I also work for 4-H in Nebraska. And my background is teaching both formal and informal science education. So I have done both. And so the next activity that the next discussion we're going to have first, before we get into another activity, is what is computer science? So my first question for you is, how would you define computer science? And you can either type in the chat or you can unmute yourself and tell us verbally. And then when you have that question answered, the next question that you can also type in the chat or unmute is, how would you define coding or programming? So is there any difference between the two to you? Or do you feel like you have a better idea of what one is than the other?
And Anne and I are both comfortable giving you time to think, but I will also warn you that we won't continue on until we get some response so that we know you've had enough thinking time.
All right, so we're starting to get some responses. So you can read through those, see if your response agrees with others, or if they had some insights that are different than yours. I think it's interesting that Wendy said it work on patterns and calculations. So she got very specific with her definition. Most other people are keeping it a little more general. All right, so as you think about this, we're going to move on to the next slide. So who wants to share their definition of computer science? So how do you think about computer science and coding and programming together to make a definition for computer science? Or is it the same thing that you've already put in the chat? And that's your definition for computer science? Okay. So on the next slide, we'll tell you what computer science is. So this is a definition that is accepted within the computer science world. So there's three components to it. It's the study of how computers are designed. It's also the study of strategies for solving problems with computers, which was what one person mentioned. Most people got that it's something related to computers. And then it's a study of designing and coding computers to do what people want them to do. Coding actually refers to creating instructions for a machine to follow, while programming involves the planning, the testing, and the debugging of your code or written instructions from the machine to follow. So that's the difference between the two. And computer scientists use computational thinking, which is the thought process that they use when they are coding and programming. And there are four cornerstones of computational thinking. One is decomposition. The second is pattern recognition. The third is abstraction. And the fourth are algorithms. And our January webinar will go into detail about the practices of computational thinking. And with this definition in mind, what parts of computer science did we use in the challenge with the palindromes? And how would a computer scientist use these skills? So you can either type in the chat or just unmute. Okay, Darren said pattern recognition. I agree. That's an important part of computational thinking, which is the part of how you think when you're a computer scientist about what you're trying to do or the problem you're trying to solve. So then how does a computer scientist use these skills? So you can look at pattern recognition. How would you actually use that as a computer scientist? They don't just color a piece of paper. So what are they doing to make that, to use that in their work? Let's add a question to that and see if this gets you thinking in a little bit different way. So computer science is about solving problems with computers, but not all problems can be solved through computer science. However, many can. So another way to think about this are what are some problems that can be solved through computer science? So if you think about your everyday lives, what are things that you have that go on in your everyday life that either already have been solved by something that a computer scientist did, or that could be solved by a computer scientist? That's a different way of thinking about this problem. And one of the examples that I would give is if you have a smartphone, computer scientists programmed that, somebody programmed that, an engineer developed that, and that gives you a whole bunch of things, like if you need to find your way in a city that you've never been in before, obviously making phone calls, so you stay in contact with friends and family. So what are some other problems that you think computer scientists have solved by doing pattern recognition or just by solving problems in general? Rebecca had a really good question. If there is a pattern, can they then use less repetition? And the answer to that is yes. There is something in programming and coding called functions. So once you are developing a pattern, you can use a function to make that repeat as many times as you want to. And so there's all kinds of complications that you can get into, but you can simplify it down with your coding using patterns. And that's one of the reasons why pattern recognition is really important, because when you see that you want a machine to reproduce something over and over, instead of typing that code 100 times, you can just put in a function that says 100 times and then write the code. And how that looks depends upon the type of language you're using, but there are definitely functions in all coding programs that I've ever worked with. And Jaden said predicting all sorts of things. Absolutely. There's more and more sensors being developed all the time for anything from agriculture and livestock to weather conditions and health for humans. And so there's definitely development in that area. And Mary Lou said, whether traffic lights are something that is an annoyance in the city that I live in sometimes, because they don't ever have them programmed to traffic. So you sit there and 10 or 11 o'clock at night and there's no traffic coming, but your light's not programmed. And so, yes, they're getting more development with that as well. So those are some really good examples. Thank you for sharing your expertise. And this discussion helps us understand why it's important for all young people to experience computer science and how learning about computer science can help youth develop their problem-solving skills. And you can use real-world applications within different activities that you do with kids to help them solve problems, or you can do things that build their skills with activities that aren't necessarily real world. There are several different ways to do that. So the next thing that we want to do is actually see this skill in action. So I'm going to share a video of a computer science event held for a group of 4-Hers by some mentors from Google. And in the video, the participants learn about computer science as they use Scratch to create an interactive story or game. You will get to try out Scratch for yourself in a few minutes. And after we watch the video, I'll ask you to share what you notice about this activity. And so the first video we're showing you is about the activity itself so that you can understand the second video where we're focusing on the skill of computer science.
Welcome everybody to 4-H and Google Hour of Code. Super happy to have you guys here and excited. I guess we're going to spend the first half hour just doing intros and answer any questions. And then we'll leave the hour of code for after that. And then anybody who wants to present their project can do so at the end.
Computer science deals with both computer hardware and software design. The most important aspect of computer science is problem solving. Young people in this video visited the Google campus in the San Francisco Bay Area to participate in an hour of code. They used Scratch to design their own games and stories. Scratch is a visual programming language and one of the most widely used online applications for introducing coding.
Hi everyone, my name is Garrett. I'm a data scientist and I work with our advertising side of the business and specifically with small shops like plumbers and moving companies to help them reach their customers.
Once they had their game or story idea, youth watched short videos that helped them learn how to write their code. Mentors who work for Google helped them develop their games or stories, as well as connect what they were doing to their own approaches to coding.
So what are you programming?
I'm trying to make a maze where like the cat has to get through it and they only have 5 lives.
At the end of the hour of code, participants shared their work with the group.
Hi, I'm Cassie. I'm a sophomore in high school. I was inspired to make this game because I have finals coming up and I feel like my school right now is just a maze, so I made a maze. And so instead of like having like a prize like a donut, I put the end because I'm like, I really want finals the end. Oh gosh. Is anyone better at playing like games? Who wants to try? Okay, do you want to come? Okay, come on.
Thank you.
So what did you notice in this video? And again, you can type in the chat or unmute if you prefer, but what things did you notice in the video? And it can be anything. All right, people of all ages can learn coding. That is correct. And this was something that they got to voluntarily come to, and it was on a Saturday morning. And I actually went to this when they filmed it, so I got to see everybody when they were registering coming in. And there was a lot of excitement about this because they got to be on the Google, it was a really nice campus. They got to be on the Google campus, and they really did enjoy this. And they had a lot of mentors there so that the kids could have help pretty quickly. I would say there were probably 30 people that were helping with the event. So that was interesting that you noticed that. It was definitely a hands-on experience. They talked about 10 minutes and then they let the kids work the rest of the time and shared their experiences and what they had developed at the end. There was definitely ethnic diversity. I think those are some very good observations. So now let's watch a second video that focuses on how the mentors are talking about computer science. And so as you watch this video, notice what the facilitators do to make the activity successful. So pay attention to how they talk about computer science and note what problems the youth are trying to solve as they work.
Run it? So first let's try doing it for like a single sprite and then see.
Hey, Python Twizzler. Cool. You are lucky.
Computational thinking strategies help computer scientists understand and solve problems. Being able to use computer science to solve problems is essential to preparing young people for a future in our quickly changing tech landscape. Watch how the mentors who work for Google support youth in using Scratch to create an interactive story or game and use computational thinking to develop problem-solving skills.
So what are you programming?
I'm trying to make a maze where like the cat has to get through it and they only have 5 lives.
So are there like hidden traps or something where they lose their life? Or?
Well, I'm gonna make it so you move like relatively fast. That way you have to have like real control over like what you're doing.
So is there a lot of logic behind this in terms of keeping track of stuff?
Yeah, I want to have it so that if they touch the color black, because that's the color of the maze, then you get docked for life and you go back to the beginning. So I have to figure out how to do that.
Questions from their mentors help youth through the process and to come to their own solutions. The mentors encourage youth to try out their new skills even if the results are not quite perfect.
So now the penguin is acting differently than the dog, right? So you also have to tell the penguin what to do. The penguin's not going to do what the dog does. So you have to say, hey, penguin, I want you to do this. Hey, dog, I want you to do this. So you can have them do like two different things. You can have them do the same thing if you want. It's up to you.
The mentors help learners see how the computer skills they are learning can now be applied to other experiences.
In programming, this is what's known as control flow, where the program is like following some sort of flow, and then you want to redirect it as certain things occur and certain criteria is met.
In terms of progressing and programming and stuff like that, do you guys understand how this relates to using a programming language like Java or C++ or other programming languages that you don't drag and drop with? So sometimes what you want to do is you want to use a different language where you actually have to type it in, and you can do things that are a little more powerful or different than you can do in Scratch.
Celebrating success helps youth process the experience and recognize what they have learned.
So is there anybody that's interested in sharing what they have come up with?
All right, so how do the mentors describe computer science? And again, you can type in the chat or you can unmute. Okay, it is a language. I think they make that clear to the kids. And you heard some of them talking about their different languages. So Scratch is one language, and Scratch is a visual language, whereas there are other languages that are text-based languages. And there were a lot of different age groups in this. So they could be anywhere from kindergarten to high school students. And so Sandra pointed out that they talked differently with different kids and adjusted to the different levels. And I would agree that was definitely happening. So what did the facilitators do to make this activity successful? So what specific things did they say, or how did they set it up that this activity was successful? Because somebody pointed out earlier that they had a high level of engagement with the participants. And so to get that, what do you think they did, or what did you notice that they were doing? Okay, provided leading questions and guidance rather than lecturing, definitely what they focused on. The majority of their time was spent doing that. And they did ask leading questions, and some of them asked questions that asked more about the information, so the students could articulate what they were trying to do and what they were trying to accomplish. So I think that was a good observation. Guiding is definitely something that they were doing as well. They were empowering the child. That's definitely true too. And the children were told they could make any story or game that they wanted to. So it was a very wide open activity. So if they wanted to do a story, and I noticed a lot of the younger children liked the stories. And when you got into the middle school and high school students, more of them liked the games. And so they got to pick what was appropriate for their age level as well. So I think those are some good observations as well. So then what problems were the youth trying to solve as they work on their programs? So thinking back to kind of what their goals were that they were trying to accomplish, what did you notice were the problems they were trying to solve? Right. They were trying to figure out the maze. And there were actually a lot of questions that were asked, because you just saw bits and pieces of that conversation in the video, but she was trying to figure out how to cause people to lose their lives, but make the game manageable enough that somebody could actually accomplish it. And so having them touch the black lines made it more difficult. Having them have to go really fast through the maze made it more difficult. And she realized she was doing it too fast, so she had to slow it down. So that was definitely one of the problems. Another person noticed creating movement. Yes, and some of the littler youth had really animated characters that they wanted to move around, and they wanted to do something really specific with, like they wanted to stab a dragon or they wanted to pick something up. And so they had to figure out how are they going to do those specific things. So that was definitely something that they were trying to solve as well. I think those are some really good observations. And so we can choose to portray computer science to youth as a future job, or as a challenging task, or as a way of solving problems. And all of these things are true of computer science. But when we focus on solving problems, it helps young people develop perseverance and grit. And you saw some of those kids were really celebrating because they were having trouble getting their program working. And when they finally got it, they were really excited about that. And it makes it easier for young people to see how they apply the practices of computer science to other real world problems. So we've explored what computer science is in a few different ways. So was this helpful? And do you feel like you know what computer science is? And you can type in the chat again or unmute, or just give me a thumbs up if your video's on. All right, excellent. So now that we have thought about, now think about the children that you work with and think about who they are now and who they might want to be in the future. So which of these children would benefit from experiencing computer science?
One of the things we were noticing in the first video was how much diversity there was, kids from different backgrounds and different ages, that we're all kind of doing the same activity.
Yeah. And I agree with what everybody said, all, or pretty much all of them. That's true, because you don't have to go be a computer scientist as a future job, because this is a thought process that helps them solve problems, and you can use it in different applications. So you don't have to be a computer scientist for computational thinking to be something that you can use, or the practices, the individual practices that you want to use in other circumstances. Engineering gets into some of these types of practices sometimes. There's a lot of other jobs that do that. So now we're going to switch from thinking about what computer science is to thinking about how to facilitate it. But it is hard to teach what you've never experienced. So we're going to start out taking some time to explore Scratch, and then we'll talk about how to facilitate it. So my first question is, how many of you have used Scratch before? You can just type yes or no in the chat so we kind of know if this is totally new for you or you've used it before. All right, that's helpful. It looks like some of you have used it a little bit and some of you have not. And then there's a few of you that have said, yep, you've used it. So what we want to do is, first of all, Scratch is a visual programming language like Visual Basic, rather than a text-based language like Python or Java. And so if you've never used Scratch, it's probably not a real good idea to go try and start with Java or Python, because those are even more complicated. And so Scratch is a little bit easier entry point into beginning coding, because you can see it, because it's that visual block that you're moving around and manipulating, rather than trying to do text-based programming where you can put a semicolon in the wrong place and the whole thing doesn't work. And you've got to figure out that your semicolon was in the wrong place. So this is a little bit easier program to get started with. And there is an online and offline version of Scratch. And we will be using the online version. So please follow the instructions in that version. And we will show you how to do this. And Sandra will share her screen and show you how to click on everything that you need to click on. The activity that we're going to do is called Animate a Name. which is part of the 2018 4-H National Youth Science Day, developed by Google, the National 4-H Council. And so my next question is, has anyone ever done this particular activity before, if you've used Scratch? For those of you that have never used Scratch, you obviously haven't done this activity. So, all right. So this will be something new for probably just about everyone then. The animated name activity, one of the advantages is that it has a lot of support for students embedded into the activities. So if you're not feeling like you really totally understand coding, they have a lot of videos that you can show students that will help them get started with this. And it's a good activity to try if you're not familiar with Scratch. So the first thing we're going to do is watch the introductory video for the animated name. And after we watch this, we'll then give you the specific instructions for you to try this on your own.
Hi, my name is Olga and I work in Google's Computer Science Education Department.
And I'm Fiona. I teach CS First classes and I'm a team leader with 4-H, America's largest youth organization where kids learn by doing. Yeah!
In this activity, you'll use code to
drum roll please.
Animate a name! Computer science uses code to give computers instructions, which is super cool because you can create anything you can imagine.
Computer science is a subject you can study in school, and it's also a career or something you can do just for fun.
You could use computer science to protect the environment, make music, launch rocket ships, save lives, and so much more.
Today you'll use computer science concepts like sequencing, events, and loops to animate a name.
To start, choose a word to animate. You could choose your name, a pet's name, an animal, a sport, a place, or anything you like.
Your animation can express the emotion or personality of the word, tell a story, or just dance and be silly.
It's all up to you! After watching this video, click the Starter Project link. This will open Scratch in a new tab. Scratch uses code blocks to give characters called sprites instructions like when a sprite is clicked, make it change color. After opening Scratch, return to this tab and choose videos to learn how to add and animate letters to make your project come to life. Watch as many videos and add as many letters as you like. And here's a helpful trick. While you work, pause a video and go to the Scratch tab to complete a step in your project. Or better yet, rearrange your windows to show Scratch and a video at the same time. Fiona, what did you make for your project?
I animated the name of my 4-H club.
Wow! Well, I animated the name of my home country, Colombia.
Now it's your turn. Open Scratch in a new tab. Title your project with the name you're going to animate. Return to this tab and select a video. Watch the video and complete the steps in your project. Then, watch more videos to complete your animation.
It's time to get creative. It's time to get coding.
Let's see. So here we go. Ready, everybody?
Wait, before you go, wait, you can make it full screen.
How do I do that?
Right there, yeah.
Okay, so here we go. I got it to bounce and I got to put a noise into it.
You're the greatest of all time.
But they didn't have a goat, so I could put a little goat down here somewhere. So
That was really good.
I like it.
So does anybody
figured it out?
One that they would like to share, whether it's completed or not, doesn't matter. You can show us what you've gotten so far.
I'll go ahead and share mine. Let's see. Can y'all see my screen?
Yeah,
Not quite yet.
You started sharing, but it's coming up.
Any
Now I
luck?
see it.
Yep.
Okay.
I love the lobster.
Thank you. You should come right side up at the end. Real quick. Let's see. There we go.
That was nice. You did a lot of animation with your name, so you always had something to look at. Well, wondering what the lobster was doing. So as he kept going around, it kept drawing your eye down to the lobster.
Yeah.
So that was really good.
Thank you.
All right. Does anybody else want to share, or are you? Everybody else is good, and we move on. All right. So. Zachary said you can't beat that. All right, so.
Oh, I'm so happy to hear that, Rebecca.
So with the animate a name, you were learning to code with Scratch. And I suspect that some of you at least were faced with some problems, or you were trying to get something to do what you wanted it to do and it wasn't quite going, or there's no goat at all. You either just don't have a goat or you've got to come up with something else. So what did you do when you had a problem? And you can either type this in the chat box or you can unmute.
I gave up looking for the goat.
Yep.
New plan.
Well, I'm excited this was your first success, because if you don't have anybody to help you with Scratch, when you're kind of coming into it and you're not familiar with coding, it can be a little intimidating. Wendy had a really good suggestion. Watch the video again, because the instructions are there and sometimes they go too fast, especially if you're working with youth that are totally unfamiliar with this, and having the video to just pause and be able to go back and do it step by step is really helpful for them.
I kind of changed my plan because I tried to have the crab just kind of going back and forth, but it was like 15 degrees in both directions, but for some reason it kept just tilting that way. So I just went for the full loop. So just changed the whole plan.
Okay, so you changed what you did. And actually, I thought it was more interesting because I was wondering what the crab was doing, since it was started going around in a circle instead of just waving from side to side, which would be more like what a lobster, what I would think a lobster would do. So I think that actually made it more interesting for me. So I think that's a really good way. Sometimes you have to change what you're wanting to do. If you can't figure out the coding is too complicated, you can sometimes simplify it to just do something that is a little bit easier for you to do. Sandra also had a good idea, just trial and error, and that is definitely true of coding. I have talked to several coders through different work that I've done, and they said coding is all about trial and error. And you try it out, and if it doesn't work, you can always delete it and you do it again. So that is definitely an option. So those are some good problem solving strategies. So hopefully this experience gave you some idea of the sense of frustration that some of your youth may have when they're wanting to do something and there's just no goat that's even there. So how cool is it when you get to do what you want to do? And so for the youth, some of this is about perseverance and grit and just working through it, because they may not get exactly what they wanted in the beginning, but they can still have something. Because like Rebecca's goat, I thought that was really good, and her background was really nice. Whether she had the goat in it or not, I never would have known that you wanted to put a goat in it. It looked perfectly fine the way it was. So sometimes you just have to modify and you're still successful. So now Sandra is going to help you process this experience and see how this applies to facilitating an activity like this.
So when we first started out, we talked about experiential learning, and I put that model up. I'm going to share that again, and let's use the Scratch experience. And I'll start the experience. The doing what was to animate our name. And I agree with you, Rebecca. I was at one of the national conferences where they were showcasing this at some event, and it was just not an appropriate place for me to learn how to do Scratch. But sitting down like this, the experience was a little bit better. How did we share the experience?
we have the opportunity to come up and kind of showcase what we made and talk about what issues we had.
And I think if we were working with kids, we may have tried to encourage everybody to share, but for the purposes of getting through our webinar today, we didn't do that. But being able to see what other people did is really one of the nice things about Scratch, that you can do that in different ways than you could if, for instance, it was a rocket workshop and they were putting together rockets. Anne asked some processing questions. She asked you a little bit about what problems you face and how you solve those problems. That is, some of those questions are aimed at helping you take it beyond this experience and think about it in terms of problem solving strategies rather than just ways that you can code. So we really wanted to connect that to the real world. And I'm kind of working on the step 4, apply, because I wanted to, part of why I wanted to have you do this was to have an opportunity to talk about this model and what it looks like in computer science. You may use this model in some other areas when you're working with kids, but may not have thought about how it works with computer science. The other nice thing about this is if I had time, we could have this discussion we just had, sharing some ideas, talking about how our problem solving strategies, and then go back into more time to work on your own. And then you can take some of those strategies that other people were using, or something that you saw in theirs, like Jaden, I really liked your lobster. So I went back to mine and I added a rocket ship just kind of in the background, because I hadn't thought about doing that until I saw somebody else doing it. So that opportunity to apply it, to go back to the experience or apply it to other experiences, really lends itself to a coding activity. The key is to take some time to talk about how things are going, to do some of that processing in the midst of the activity, not saving it all until the end, which we kind of did here. We're not modeling that well, but getting that processing time into the activity itself is really crucial. And I think we are ready to talk about some strategies for teaching computer science or facilitating the experiences. So Anne's got the whiteboard here for you, and you can write on the whiteboard. If you haven't done this before, you need to go up to where it says view options and click on annotate. I'm not finding that. Why can't I find that? Is anybody else finding annotate?
No, I think it's a permission that needs to be provided, but and I don't know
That's what I was wondering.
setting it up or not.
I changed a setting. Let's see if that worked. Oh, I hate this when the technology doesn't do what I want it to. Okay, I'm not sure if I can change that setting right now. And maybe you need to do that.
Let me see if I can. On my security, I don't have an option to do that.
Try under the advanced sharing options and make sure that all participants can share. And multiple participants can share. That's the only thing I can think of.
All right, well, let me go see. We didn't have this problem when we tested it.
No, of course, it worked fine when we were doing it in our testing. So those are by share screen.
Yeah, I have it marked as multiple participants can share simultaneously. And let's see here.
Do you have all participants can share? I can't change it.
It does not give me that option.
Okay, so no, what?
Maybe we'll do it in the chat.
Yeah, so share your ideas in the chat. What we want to do here is we want to brainstorm what are some strategies you've used when you've been doing computer science with kids, or some ideas that you want to try. And Anne's typing in some of the strategies that we've highlighted as examples so far in the workshop. We started out with an unplugged activity, the palindrome, and a lot of the computer science unplugged activities that I've seen are sort of paper and pencil activities like that, where there's some worksheets that they're working with and they're using those computational thinking skills. There's also some physical sort of embodying the concept activities that you can do. We've talked about experiential learning and what that looks like in computer science. We also did some self-directed learning, and Scratch really lends itself to that you can have the kids working on their own. Oh, Rebecca, we'll have to have you show us your goat before we finish. Anybody else have strategies that you find helpful for CS learning? We've had some really good CS activities in some of the National Youth Science Days or STEM challenges, like this animate a name, that we pulled that from the National Youth Science Day. And there are others like that that are fun to do. Oh, coin flip, rock, paper, scissors. That was in one of the National Youth Science Days too. What else are people using? Our curriculum, I think that's a good question that Jaden asked. Has anybody used Scratch with kids? Have you found that to be useful? One of the ways we're using Scratch is in some of our virtual or distance programming, where the person facilitating the activity isn't actually in the room with the kids where they're doing their Scratch programming. But there's so many cues and helps built into Scratch that it works pretty well for that. Kind of like what we're doing on the workshop today.
And to answer the question about curriculum, there is some really good curriculum that has been put out by MIT on Scratch, and it has a lot of different activities that you can pick and choose them, do individual activities, or you can go through it as a whole curriculum. And I know that some groups have used those as like a coding camp. They've used them for that. They use them just as like an hour of code activity or in after school settings. And Scratch is pretty versatile because you don't necessarily have to have some of the equipment that you would have to have, like if you were going to program Arduino, or you have makey-makeys and those types of things. And so it's a little bit easier to get started with for the amount of hardware you need as well.
Anybody have things they're looking for? The specific things you'd like the kids like to be able to do with the kids, or anything? Well, we've got a little bit of brainstorming power here with everybody on. We're gonna save these ideas, and we'll add a little bit to them. We'll take some of the things that you shared and add links so you can find those curriculum, and we'll send that back out to everybody. So any other ideas that you want to share, go ahead and keep typing those in the chat, but I think I'm going to move on to our next activity.
I had a quick question with if you have experience with this, but of course at the Google example, they had, you know, all these beautiful computers, and but I'm wondering if like the online version or I guess the other version at least, if it's pretty usable on multiple devices like Chromebooks, and which seem to be limited with some other, you know, compared to other, you know, hardware or whatever.
Scratch is one that you can do on Chromebooks if you're using the online. So, but you'd have to have a place where the kids have internet connections, preferably, you know, someplace where they can connect to Wi-Fi. A lot of schools can do that, but if you're programming in other places, one of the things that they did with the National Youth Science Day is they have those offline versions. So if you've got laptops, you can actually load it onto the laptop and they can work on it that way, and they don't have to connect to the internet. So if you're, you know, doing it in a church basement and you don't have very good internet connections, if you've got enough laptops, that works really well. I haven't used Scratch on a tablet, but I think it works that way. I would have trouble with the drag and drop. Kids might find that much easier than I would. But Scratch is really versatile in terms of what equipment you need to make it work. Some other things aren't. I think that Lego is getting better with having their software work across different platforms. And Scratch and Lego are kind of coming together. The new Lego programming interface is like Scratch, is a visual programming language, so they can, those skills cross over better.
We also had Wendy said that she has an older kid that wants to do a text-based programming like Python. Do you have any recommendations for Python?
I don't now. I have not gone that far with kids, but I'd have to go back. We may have some things coming up soon on Click to Computer Science. I know Mark is working on some of those more advanced resources, but I don't think they're quite there yet. But that's a good question, Wendy, because if you start this, you don't want all your activities to be at this beginning level. It needs to grow with the kids. All right, we are coming up to the end of our time, so I wanted to go back to our agenda, and this is what we meant to do today, and I hope you feel like we accomplished this. If you still have more questions, we will stick around for a little bit so you can ask some more questions. But I want to kind of wrap up with this idea that we're not teaching computer science just to create more programmers. It's really not about getting kids into these jobs necessarily. There's some deeper, bigger picture things here about how we do our work. And that's what I want to do our last little bit of brainstorming on. And we don't have a lot of time, but what are some of those bigger picture things? Some of the kids are definitely going to be interested in this as a career, but what is the value besides that? for the youth we're working with. Why do we do this? Problem solving. So just kind of summarizing some of the things here, we're seeing some skills that are going to help our youth be the workforce of the future. Problem solving, logical thinking. Those are skills that are going to benefit them in whatever career pathway they take. There's also some life skills. I guess problem solving even is a life skill, following directions. I love how they learn perseverance when they're doing robotics. They're really willing to keep at a challenging problem so they can get it to do what they want. And helping them see how those are skills that they can use in other areas is really important. I also want to be real honest. Kids, when we can bring computer science to our youth programming, we're allowing them to develop skills that may open up a whole different set of job opportunities that may, especially for kids that are coming from low income or rural areas where they feel like they don't have a lot of opportunities. It really helps broaden their perspective and think about different sorts of careers that they can consider. Computer science or computational thinking and coding are skills that are used in so many careers, marketing or fashion, but also being a mechanic or just anything that they might want to do, that they might find a way to build computer science and coding into that career. So that is really what we want to accomplish with Click to Computer Science. We want to make this something that all young people have access to and bring resources into out-of-school programming that they can use. All of the resources we pulled today, the activities like Animate a Name, the videos that we watched, all of those are on the Click to Computer Science website. So they are all things that you can access whenever you want to on that site. So I want to encourage you to visit that. And I will share that link in the chat. And you want to go ahead and stop the recording for